Hello, welcome to the class. I'm Laura Lewis, and this is class on density. This will be classified as part of physics. Okay, let's start the presentation. Okay, density. So let's look at learning aims first. So number one, an explanation of what density is and how it is calculated. Number two, how density is applied to situations in the real world. And number three, examples of calculations involving density. So what does it mean, density? So if we look at these two objects, they are both 1 centimetre cubed. So 1 centimetre cube is about the size of a sugar cube. Okay, so we've got ice and we have lead. So the ice, its mass, if you look at the bottom here, its mass is 0.917 grams. And the mass of the lead is 11.3 grams. And you probably say straight away, the lead is more dense. Okay, but you think, how would you explain that scientifically? Because it'd be correct, but how would we explain it scientifically? So lead is more dense because lead has a higher mass than the ice. Okay, it means there are more particles of lead squeezed into this 1 centimetre cubed volume. Okay, so yep. And ice, actually, it's an interesting thing actually, as water freezes, it becomes less dense. Okay, water freezes, so that's why you see ice can float in a drink, or you see icebergs in the ocean. Okay, so density, what does it mean? So what does it mean to be, so which of these is more dense? In this case, you've got the mass, 200 grams, mass 200 grams. So they both have the same mass. Let's look at the volume. So how much space it takes up. So you have 5 by 5 by 4. This one's 5 by 5 by 2. Okay, so it's got, that one is twice as high, okay, as that one, twice as thick as that one. They've got the same mass. You probably go, well, that will be more dense to pick up. But again, explaining why scientifically. So sample B is more dense. It's because sample B has a smaller volume than sample A. Yeah, we noticed that. This means that although there are an equal number of particles in each sample, because the mass is the same, in sample B, the particles are closer together. So I also used an example. I actually had some modelling clay. We had sort of a mass of it. And one person sort of squeezed it and made it into like a boat shape, so like a bowl shape, that would float on the water. Okay, but if you sort of squeezed it down to a very small ball, it might sink. Okay, so because you've increased its volume, the other one, without changing its mass, you add anything or take it away. Okay, you've just spread it out so it's less dense. Okay, so that's what happens there. Okay, so density, what does it mean? A little recap from these two examples provided, we can see density of a substance relies on two things, the mass and the volume. Okay, so the mass of a substance is defined as measurement of the particles that can fit within a total volume. And substances that have larger masses will have larger densities, okay, if the volume stays constant. And substances that have smaller volumes will have larger densities, again, if the mass stays constant. Okay, so it's kind of just going over what we just talked about. So we talked about terms of in relation to water. So it says, does it float? So to sink, an object's density must be higher than water's density. So water's density is 1 gram per cubic centimetre. That's nice and easy to remember. Okay, to float, an object's density must be lower than water's density. Okay, so look at butter, 0.86 grams per cubic centimetre. That's less than 1, so butter would float on water. Gold, 19.32. That's more, it would sink. Vegetable oil, like cooking oil, 0.93 grams per centimetre cubed. So it is less dense, it will float. You probably know that oil floats in water. A brick, 1.92 grams per centimetre cubed. Actually, not that high, really. It's just a brick's big. Definitely sink. And this is a piece of coal, so carbon. So 0.57 grams per centimetre cubed. So it actually will float on water. So if we look back at the ice cube, I said it's less than 1 gram per cubic centimetre. It'll float. Then we know ice floats in water. Okay. So if you were tasked in an exam or any sort of test to measure the density of a solid you had in front of you with lab equipment, Okay, you need a balance. Okay, that measures the mass of an object. You need a ruler to measure its volume and a calculator to do the calculation. Okay, so yeah, so you get the mass in usually put in kilograms. Okay, the volume usually want it in meters cubed. We can talk about in a minute. So the density is mass, the mass divided by the volume. So that's just obviously how to measure it. If it was a liquid we were talking about, again, we get a mass, okay, but also a volume can be taken directly. Because if it's, for example, you can pour as a liquid, you pour it into the measuring cylinder, and it's got measurements on the side. You'd measure it from what's called the meniscus, so that's the bottom of, sort of the curve. But if you look at some liquid in a measuring cylinder, it forms like a little curved surface. So you measure from the bottom there. So you need to put it on a flat surface and measure from the bottom there. Okay, so that's the meniscus. To find the mass, we could do it one of two ways. So what I would do, I put the liquid and the cylinder. So so you can do it two ways. So you put the liquid and the cylinder like it is there on the balance, and then you pour the liquid out and then look at the mass of the graduated cylinder and take it away from that to find the mass of the water or liquid. Or you could put the mass of the graduated cylinder. So you could put that directly onto the scale, press the 0 button or tare, T-A-R-E, and then pour in the liquid. Okay, so it goes to 0 and that's on, then you can find directly the volume. Okay, same calculation. The density is mass in kilograms divided by volume on a calculator again. So same procedure really. Okay, so here's a formal definition. Okay, so calculating density equals P equals so P rho. Okay, so density is rho. Okay, sometimes you might say it's P, but rho is a proper unit. So kilogram per cubic meter. So density rho is a Greek letter. Is mass. Okay, if you forget, just write the word density. If you forget that letter, don't worry. You can write density, it's fine. Is mass. Okay, and kilograms. Kilograms is the SI, so scientific unit. We prefer to use, and volume meters cubed. So yeah, generally you want things kilograms per meter cube. You can do things in grams per centimeter. Okay, depending on what you've been asked to work out there. Okay, as a general rule, we say kilograms per meter cubed. Okay, so there's some units to think about. So 1 kilogram is 1,000 grams. You might know that from a bag of sugar. Okay, so usually buy sugar in, if you drink tea like me, you definitely buy sugar. So sugar is in 1 kilogram bags or flour. Okay, make bread and things. So if you probably know that if the recipe had 4 lots of 250 grams of flour, you probably know, well, that's a whole bag of flour. Okay, so you know it's 1,000 grams. But people often get that wrong in science, but probably cooking you probably get it right or something. Okay, 0.01 so 1,000th of a kilogram is equal to 1 gram. It's just this reversed really. It's like saying that 1,000 grams make up a kilogram. If you know that, then you can work out that. Okay, it's an interesting one. 1 meter cubed. Do you think, oh, that's a massive number? Why is that? To work out how many centimeters cubed, 1 meter cube is 1 meter by 1 meter by 1 meter. Remember, and that's 100 centimeters by 100 centimeters by 100 centimeters. Okay, so 100 times 100 times 100 is actually 1 million because you add up all the zeros. So 100's got 2 zeros times 100. Okay, so then I'll have 4 zeros times another 100 would have 6 zeros. So I didn't actually know that trick until I was an adult, that if you multiply things together, so 100 times 100, those two numbers have 4 zeros, so the end result will have 4 zeros. It's a good trick. Okay, and again, it's the other way around, so it's 1 millionth, okay, of a meter cubed is 1 centimeter cubed. Yeah, this is a little bit hard to get used to, but always think about a meter block being 100 by 100 by 100, and you'll be able to do it. Okay, so we're going to this is useful to you. Okay, rearranging. You can sort of pause and screenshot this. Okay, because we're going to do some practice with some questions. Okay, so let's go on to our questions. Okay, so We've got some problems. So just some questions. Okay, so we've got a formula triangle at the top there, I left it on. Okay, so let's look at doing an example there. So this is better from tests. Okay, we can do them. So the student measures the mass of an 8 centimeter cubed block of brown sugar to be 32 grams. What is the density of the brown sugar? So we haven't been asked to do it in a certain unit, so we can do grams per centimeter cubed. I said that generally if you have to go with what we're asked. Okay, but it hasn't been asked for anything, so let's go in grams per centimeter cubed. Okay, so we know that density equals this mass divided by volume. Okay. So I've got mass is 32 grams. We'll check everything. Divided by 8 centimeters cubed. I'm not easy for just to go. Not going to be near the 8 then, is it? Okay. Probably could do that in our heads, but we'll show in a calculator anyway. It's be 4, isn't it? So sometimes though, if you really a test or an exam, you get a bit of a panic on, don't you? So don't worry about using a calculator for even basic things. I do it all the time. Okay, because sometimes you just go, is it? So 4 grams, right? You also have to state your units all the time. So we can use different units, but we just need to say what they are, okay? So I thought something happened wrong, but no, it's still recording. Okay, 4 grams per centimeter cubed. Okay. When you finish an answer, to make the person aware it's marking it, always underline it like that. Okay, so let's look at the next one. A chef fills a 50 centimeter cubed container with 250 grams of cooking oil. What is the density of the oil? Okay, so again, just density equals mass divided by volume. Okay, so mass 250 grams divided by 50 centimeter cubed. Use a computer, you can just kind of copy and paste like this. I'd always recommend doing maths things just to get your pencil and paper and to do it because it's easier than trying to fiddle around with the computer. If you're good at it, that's fine. Okay, 250 divided by 50, 5. Okay, so 5 grams per centimeter cubed. It's very dense cooking oil. That could be a different type of oil. We had earlier. We've got different types of oil. Okay. So just always just go with what's in the question. Okay, so we've got a bit of a different one. Oh, underline. So I'm going to start people to always underline. So the person marking it knows you finished. You underline. A piece of cork. So sort of like you're getting a wine bottle. Okay, sometimes on cork tiles. Has a mass of 24 grams and a density of 6 grams per centimeter cubed. What is the volume of the piece of cork? So we can either rearrange or we can look at the formula triangle for that one. Okay, so we'll look at the volume. Okay, so it's mass divided by density. So let's write, I'm going to do it 2 ways. You use it formula triangle. I'm going to show you how to do it different ways. So I would write out what I know. Density equals mass divided by volume, and we need the volume. Okay, so volume, if we times both sides by volume, you get volume times density. So I'm going to show you the maths operation here. Volume times density. We multiply both sides by volume here, equals mass. And we want volume on its own. We do volume equals, so we're going to divide both sides by density now. So it's mass divided by density. And you can see, if you covered up this one, you get mass divided by density. It's the same thing, okay, but I'm just doing it. It's called rearranging it when you do it like that. Okay, so volume, that's what we didn't know, equals mass, so 24 grams. divided by the density. So we're just going to just copy and paste what we have here. Okay. Oh, yeah, that's fine. That's right units, and that will equal. I'm going to get a subscript here. It's writing a bit small. It's something called a superscript when it does that. Okay, so let's get a calculator out. I'm sure we'll do it our heads again, but let's do it. 24 divided by 6. Okay. Yeah, divided by 6. Yes, 4. Okay, so its volume is 4, and remember the units here, centimeters cubed. That's when people go a little bit wrong. It's the units in this. I forget what units they're using. So volume is a centimeter cubed or cubic centimeters. Sometimes it's known as centimeter cubed because it's asked for the volume. Okay. So always be careful what they're actually asking you. Oh. So a carver, so someone that carves things, begins work on a block of granite that has a volume of 1,000 centimeters cubed and a density of 5 grams per cubic centimeter. What is the mass of the block of granite? So yeah, we've got a slightly different one. Got a volume and a density. So we want the mass. We go to our formula triangle. Mass is, we've covered that up. Mass is density times volume, but let's do it the rearranging way. So again, we know density equals mass. So yeah, the way to get good at physics and anything really, isn't it? It's just to keep doing things over and over again. So I got good at maths. Mass divided by volume. We'll get so everyone gets good at anything, isn't it? Really. Okay, so what would we want? We want the mass. Okay, so we need to multiply both sides by volume. So we get density times volume is equal to the mass, and we're done really. That's as hard as it was to rearrange that. Okay, so yeah, so mass is density times volume. So I'm just going to write that round a nicer way. Same thing as the one above, but this line above, but I'm just writing that a different way. Around. So let's put that in. So mass equals density 5. Yeah, 5 grams per cubic centimeter. Should just copy and paste that. Copy, it'll be easier. Okay. What we're doing is multiplying. It's just straightforward. Times by 1,000. Okay, and volume. Yeah, it's really just the units that are most challenging here. Okay, I think we'll probably have to put this one out, won't we? Over 5 times 1,000. Okay, equals 5,000. 5 times 1,000. Do that one. Grams. Okay, so if we look there, it's grams. If we have used centimeters. Sorry, grams per centimeter cubed. Centimeters, so we're going to get grams. Okay, not kilograms. That's another mistake. It's easy to make. Always keep consistent. It's called. Sort of like make sure it's the same as what you've used. Okay, let's have a look at another one. A box has a volume of 55 centimeters cubed and a density of 5 grams per centimeter cubed. What is the mass of the box? Okay, if we've done it once already, we can just write it straight out, can't we? Density times volume. Okay. So copy and paste. Oh, I'll be consistent, do it in the same order. It doesn't really matter if you're multiplying. It doesn't matter, you know. But we'll be consistent today. Okay. 5 times 55. 275 grams. Okay. Underline that. Oh, just underline that onto the over for. Okay, underline. Okay, so there's some examples to do yourself. I recommend you to attempt them yourself. Okay, to do. As I keep saying, the best way of doing it is just to keep practicing. and you can always pause to go back to, I'll do a bit of a shot here, so you can sort of take a screenshot there. And there's also the formula triangle up here as well. Okay, so how it works. So you can remember it by the definition, going through it, okay, or you do the formula triangle. So thank you very much for joining the class. Hope to see you another one. Thank you and goodbye.